Hello everyone. I want to talk about implicit functions, implicit differentiation. We need to master how to differentiate implicit functions. So the question says, find the slope of the tangent to the curve. Equation of the tangent, find the slope of the tangent to the curve xy cubed minus 2x squared y squared plus x power 4 minus 1 equals to 0. At the point where x is equal to 1 and y is equal to 2. So this is a good question involving implicit differentiation. What we do, we take the derivative of the given equation. So, okay, we take derivatives of both sides with respect to x. So we have d by dx of xy cubed minus 2x squared y squared plus x to the fourth power minus 1. Okay, this is equal to d by dx of 0. Okay, so the first term here is a product of x and y. So what we do, we keep x constant and take the derivative with respect to x of y cubed. Then plus. Now keep y cubed a constant. Take the derivative with respect to x of x. So that's the product rule. Then the second term is a product of x squared and y squared. So I have a 2x squared. Take the derivative with respect to x of y squared. Okay. Then plus. Okay. So let me put a parenthesis right here and they say plus. Okay. 2y squared. Take the derivative of, so this is we better write this as y squared. Take the derivative with respect to x of 2x. Okay. So then plus the derivative with respect to x of x to the power 4. Then the derivative of 1 is equal to 0. Their side will be equal to 0. Okay, so every time you take the derivative of y with respect to x, you have to write dy dx. So the step that comes after here will be d. I write this as x. Okay, then I have 3y squared. Now this is the y by dx plus y cubed. The derivative of x is equal to 1, so I don't need to write dx, no. Okay, I only write the y dx every time I take the derivative of y. So this is minus 2x squared, okay, times the derivative of y squared, which is 2y, but we have to write the y dx. Okay, then minus, this will be y squared times 2, okay, then plus 4x cubed. This is equal to 0. So the next thing you have to do is to bring the dy dx terms together and throw the rest of the terms to the right hand side. Okay, so this is what we do. Let's go to the next slide. So collecting like terms will give us 3x squared, 3x squared. So you have this as 3xy squared, okay, minus 4x squared y. These are the terms involving the y dx term, okay, will be equal to, so if I throw the rest of the terms to the other side, I have minus, this will be plus 2y squared minus 4x cubed plus y cubed. It is a minus y cubed, okay, not a plus, it is a minus y cubed. So this goes to the right hand side, this goes to the right hand side, this goes to the right hand side. So they will switch their signs and become positives, become negatives, and negatives become positives. Okay, so what happens after? We have this as dy dx, dy by dx. So dy by dx is now equal to 2y squared minus 4x cubed minus y cubed, okay? Divide this by 3xy squared. then minus a 4x squared y. Okay, so the next thing we have to do is to plug in, because the question says find the slope of the tangent to the curve at the point x is equal to 1 and y is equal to 1. So we need to get dy dx. What is dy by dx when x is equal to 1 and y is equal to 2? So it's all about plugging in. X is equal to 1, y is equal to 2. So wherever there is y, we plug in 2. So 2 squared is a 4, so this will be 8. Minus x is equal to 1, so this is a 4. Minus, okay, 8, because 2 cubed is 8. Then down we have this as, okay, 3xy squared. Y is a 2, so when I square, that is a 4, this will be a 12. Minus 4x squared y. So x is equal to 1, y is equal to, this is 8. So my derivative here is negative 4 divided by a positive 4, which is equal to negative 1. So the slope of the tangent line, okay, slope of the tangent line is equal to 1. Okay, we have this question. It says find the equations of the tangent line to the graph y minus x squared y squared plus x squared plus 1 is equal to 0 at the point where x is equal to 1. Okay, so the first thing we have to do, we need to take the derivative, but we need to see which y values correspond to x is equal to 1. So what I'm going to do is to plug in, okay, when x is equal to 1. I have y minus y squared plus 1 plus another 1, okay, this will be equal to 0. Yes, so we have y minus y squared plus a 2 equal to 0, which is a quadratic. You can write this as, okay, y squared minus, so it is negative y squared plus y plus a 2 equal to 0. So the y values, if you solve this quadratic equation, you'll get the y values as y is equal to negative 1 and then y is equal to 2. There are two y values, okay, corresponding to x is equal to 1. So x is equal to 1 has two y values. Okay, next step, what we do, we take the derivative of this implicit function. So taking the derivatives of the implicit function, take the derivative of the implicit function with respect to x, you have d by dx of y minus xy squared, okay, plus x squared, then plus a 1 will be equal to 0. So what we do, we take the derivative of a y minus, okay, we keep x constant and take the derivative of y squared, okay, plus keep y squared constant, take the derivative of x, okay, then plus take the derivative of x squared, okay, then plus take the derivative of a 1. This is equal to the derivative of 0, which is equal to 0. So the derivative of y is dy dx minus the derivative of y squared is 2y, so 2xy dy by dx, then plus, okay, this is y squared, the derivative of x is equal to 1, then plus 2x, okay, equals to 0. So the next step is to correct like terms. So this will be 1 minus 2xy. So these are the terms involving dy dx, okay, minus y squared plus 2x equal to 0. So the next step is to write dy dx is equal to y squared minus 2x, and then we divide by. So that's what we should do, and then we plug in the points. So you have dy by dx equals to y squared minus 2x over 1 minus 2xy. So that's the gradient function. This function gives us the slope at any given point. So we have x is equal to 1. We want to see what is dy by dx, okay, at x is equal to 1 and y is equal to negative 1. Because there are 2 points of y that correspond to x is equal to 1. What happens is that x is equal to 1 and y is equal to 1. So this will be equal to, okay, negative 1 squared is a 1 minus 2 divided by 1 minus 2. Okay, so 1 plus a 2, because x is equal to 1 and y is equal to 1. So this is negative 1 out of 3. Okay, and then the equation of the tangent line will be y plus a 1 is equal to negative 1/3 of x minus 1. So the next step is to make y the subject and have that as the equation. But what happens at the other point when x is equal to 1 and y is equal to 2? Let's see. So dy by dx at x is equal to 1 and y is equal to 2 is given by y squared minus 2x. Y squared is a 4 minus 2x is a 2 over 1 minus 2xy, okay, over 1 minus a 4. So this is 2 divided by negative 3, okay. So we have the slope at this point when x is equal to 1 and y is equal to 2. The slope is 2 divided by negative 3. So the equation is y minus 2 is negative 2 over 3 of x minus 1. And these are the equations of the tangent line to the curve at the given points. So that's what they wanted you to do. Okay, question says calculate dy dx by implicit differentiation. Okay, if you have, okay, if you have x squared e to the 2x plus y equal to y squared over 2. So find y dx, dy by dx by implicit differentiation. So the left hand side is a product of two functions, a power of x and an exponential. So what do? We take the derivatives, okay? D by dx of x squared e to the 2x plus y will be d by dx of y squared divided by 2. Okay, so you keep x squared a constant and take the derivative with respect to x of e to the 2x plus y. Okay, then plus keep e to the 2x plus y. Then take the derivative with respect to x of x squared. The right hand side will give us it will give us 2y over 2, which is y, 2y over 2, okay, dy by dx. So let's take the derivative of the left hand side. We have this as x squared, okay, x squared e to the 2x plus y. You know, when you are taking the derivative of an exponential function, you take the derivative of the exponent and then multiply, okay? So I want to take the derivative of e to the 2xy. So I write it to the 2x plus y, and then I take the derivative of 2x plus y, which is 2 plus dy by dx, okay? This equals to, okay, plus, this is 2x e, the 2xy, 2x plus y is equal to y, dy by dx, okay? So that is also important. If you know how to take the derivative of exponential functions, then that's very, very important, okay? So next step is to now collect like terms, bring the dy dx terms together, and then you have dy dx. Okay, so what do? We bring dy dx terms together, okay? So I have a dy dx on the right hand side. What I want to do, I want to get the term on the left hand side involving dy dx and throw it the right hand side. Okay, so we have this as x squared, okay? We have 2x squared e to the 2x plus y, okay? If I'm now opening the parenthesis, okay, plus 2x e to the 2x plus y. This equals to y minus, okay, this will be e to the, okay, there's x squared e to the 2x plus y, then dy by dx, dy by dx. So if you make dy dx the subject, okay, you'll have this dy by dx. So dy dx is equal to 2x. Okay, if you want to factor out something, e to the 2x plus y, and then you have x plus a 1. Divide this by y minus x squared, e to the 2x plus y. Okay, and that is what the question wanted you to do, to find y dx. So go and try as many questions as possible on implicit differentiation. Then when you feel you are set, you can now come back and retake a quiz 4 if you not get a desired grade. So if you want to improve your grade on quiz 4, so it's good to look at what we covered yesterday, chain rule, and what we have covered today in implicit differentiation, and then come back and sign up for the quiz. All right, I wish you the best.